Hi, this is Tom, amateur reader call sign N8FDY, and it's time for another meter review. This time, it's the Uni-T UT181A. Comes in a nice case. Comes with leads that are plasticky, but they're not as tough, but I would get new leads. Has a Cat 4 protector on them. Comes with the manual. English is in the second half of the manual. Comes with 2 thermocouples because it can measure 2 at a time. It comes with the adapter to charge it. It has a charger. This is not what came with it. A European adapter came with it, which of course doesn't work for me, so I found a appropriate adapter in my junk drawer. It also came with a optical interface to USB, so you can connect this meter up to some Windows-based software that the Uni-T provides. You can download from their website. Here is an adapter for the thermocouple, so it can take 2. While you're charging this meter, you can't use it for anything else. The charging adapter makes sure that all the holes are blocked and only the charger will plug in. And you have to switch the meter over to charge mode. Let's get out the meter. Put this away. There's one other thing that did not come with the meter, but I bought it for $29.99 at Amazon, is this Bluetooth adapter that works on this meter, and it works on a couple other Uni-T meters. I got this meter for $3.99 at Amazon, but I got it from the Uni-T Direct store. You can buy this from other vendors, and if you do, you won't get the USA warranty. But if you buy it from Uni-T Direct, and there are other stores called Uni-T something else that aren't really official stores. The only official Uni-T store in the US is the Uni-T Direct and Amazon, and if you go to their store page, you'll find it tells you that they give an 18-month quality warranty, they call it. So if there's any problems, they'll fix or replace the meter for 18 months. You also get the Amazon 30-day return, which Uni-T Direct honors that also. So this uses a color screen. Let's see if we can show you that. We will turn it on with the on button. It's a little unusual that it has a separate on button that isn't related to this rotary switch. And you see that it's one of those reverse screens where it's white letters on dark background. And the backlight button actually turns off the backlight. All right. Also, this has a setup mode. So when you go into setup, using these menus, you can actually adjust the timeout for power off and for the screen to dim and for the screen to go off. I find it hard to read the little red background, but that's how you see what menu option you're on, is the little red background. Anyway, there you go. You can adjust the screen dim, screen off, and power off, which I think is really handy. This uses a rechargeable battery, which I mentioned before, and here's the symbol for that. We're about half through. This meter is third-party safety tested by ETL. Let's go into some of the other features of this meter. third-party safety tested by ETL. It has trend capture, has data logging, 20,000 points, has data comparison, has an LCD color screen. It can measure 2 temperatures at the same time, has a low-pass filter. It has a 2,000 milliamp hour lithium-ion battery. It has a real-time clock to keep track of time and date. It has a peak hold. It has free Bluetooth apps for iOS and Android. It has a USB interface cable included that has software that runs on Windows PCs to talk to the meter. It has an IP65 rating, and it has an 18-month warranty if you buy it from the Uni-T Direct store at Amazon. Let us try some voltages. Here is 2.5005 volts DC, and it reads it as 2.5005. Here is 5.0009, and it reads it as 5.0009. This is 7.5016, and it reads it at 7.502. This is 10.0015, and it reads it as 10.001. There is a written review that goes along with this. It's in the description of the video, and that has all the details of all the voltages I measured. This meter missed 1 voltage in the 490 range. It was off by a little bit, but every other voltage was within specification. All the DC voltage readings except one met the specifications as stated in the manual. The one that it missed, the 490 volts, it was 155.4 millivolts off. I'm using my arbitrary waveform generator to generate a 60 hertz sine wave at 2 volts, or as close to 2 volts as this generator can do. Here's a table with the rest of the AC voltages. All the AC voltage readings met the specifications as stated in the manual. We have 2 volts AC and 3 volts DC, which both show up here. And if we took the square of 2 and the square of 3 and added them together, we'd get 13. If we took the square root of 13, we would get 3.60. So this thing does true AC plus DC RMS. The AC plus DC true RMS readings taken met the specifications as stated in the manual. We're going to do some dBms. Okay, we have arbitrary waveform generator putting out a 10 dBm AC signal at 1 kilohertz with an output impedance of 50 ohms. We have this meter set up to use a 50 ohm impedance and to measure dBm, and we have here a 50 ohm resistor that's terminating the end of the line. And as you can see, the meter says 10 dB, 9.99, and the generator's putting out 10. Let's put out 20. There's 20 dB. Meter's reading 20. Let's take it up to 5 kilohertz. There's 5 kilohertz. Still reading 20 dB. Let's take it to minus 10 dB. There you go. 5 kilohertz minus 10 dB. So it is handy to have a meter that can measure dB, and you can adjust the impedance. Normal audio circuits, professional audio would be using 600 ohms, and that's, you can set this meter to 600 ohms if you want. It could go all the way up to 1200 ohms for dB measurements. And you could measure for a speaker, because it also does 4 ohms and 8 ohms and 16 ohms for speakers. Now it's time to measure some current. I plugged the current in, but I don't have it on current, so let's switch over. We're going to have it on microamps. Let's make sure it's DC. Yep. DC microamps. We're going to use my current board, which has some constant current circuits. You may wonder why there's a gigantic heat sink on this one circuit, which is 99.4 milliamps. Well, I've discovered that these circuits tend to drift even if they get a little bit of increase in temperature. So I'm trying to keep them from drifting, so that's why they all have heat sinks now. These other lower current ones don't drift because the circuit I'm using has a diode in it that actually compensates for the drift. So, and I'm using a battery to avoid the noise of a power supply. Here we go with 0.89 microamps. And we get 0.89 microamps. Excellent. Here is 9.21 microamps, and we get 9.20. Oh, 19, 20. Oh, 21. A little bit of drift. This is 99.0 microamps. And it reads 99.03. Here's 131.8 microamps, and it reads 131.92. Now you may wonder how I know what the current is here. I'm using a Keithley DMM 6500 that I measured all the currents and all the resistances and all the voltages and all the capacitors. And that's a 6.5-digit high accuracy meter. I know it's not an 8-digit, but 8.5 would be great, but I can't afford those. But that's the closest I can get to a standard, and I think it works fine for comparing these meters. Here's 1.00 milliamps, and we're getting 1.00789. 1.008 is about the middle. Here's 9.98 milliamps, and we're getting 9.99. Here's 99.4 milliamps, and we're getting 99.41. The AC measurement that I took was off by 38 microamps. That's not much, but it just didn't meet the specifications as stated in the manual. All the DC currents that I measured met the specifications as stated in the manual. Comparing the voltage and current specifications for this set of meters, we see that the Uni-T doesn't have the worst or doesn't have the best. It's pretty good, but it's third place. It did miss one reading in the high DC voltage range that was out of spec, and it did have one reading in the AC milliamp range that was out of spec. But outside of that, they all met specifications. Here is some resistant value. I switched it to resistance, but I didn't change the lead yet, so that's why it was complaining. Let's put it here. All right. Let's test the leads. We're getting about 14. Let's see if we can rel this out. Oh, you have to do the rel with the menu. Here's a 1.004, and it shows as 1. Shows up at 98. I bet you I didn't zero these leads good enough. Let's see here. Here's 1.004, and it's 1.03. Here's 10.007 ohms, and it's 10.03. All right, we'll go 10.02. Here's 100.069, and we get 100.0302. We get a 0L because we're in delta mode and we're stuck in the low range of ohms. So to get out of this, we just tell it to go back to ohms and take it out of relative. So we're back on auto. So this is 1.0001 kilo ohm, and this is 1.0004 kilo ohm. This is 10.002 kilo ohms, and we get 10.004. Here's 100.02 kilo ohms, and we get 100.09. Here's a 0.997 mega ohm, and we get 0.9954 mega ohms. Here is 9.97 mega ohms, and we get 9.977. All the resistance measurements met the accuracy specification as stated in the manual. The accuracy specification for the ohms and kilo ohms ranges was the best in this group of meters. The accuracy specification for the 60 mega ohm range was the worst of this set of 5 meters. Now we're going to do some capacitance values. Check the stray capacitance. It's about 12. Let's delta that out. Again, we have to do it through the menus. And they call it relative, not delta. There we go. Now let's try it again. There we go. Let's see what happens. This is 12.36 picofarads, and this is reading it as 0.011 nanofarads, which would be equivalent to about 11 picofarads. Oh, now it's up to 12. So that's pretty good. Here's 102.56 picofarads, and this reads it as 0.102 nanofarads. Oh, now it's 0.103 nanofarads, which is equivalent to 103 picofarads. Here is a 1.005 nanofarad, and we get 1.006. Pretty close. Here's 9.921 nanofarads. Oh, overload. That's because we're in relative mode. Let's get out of relative mode. Menu, capacitors. Now we're back in auto. This is 9.921, and now we get 9.96. Here is 99.51 nanofarads, and we get 99.6. Here is a 1.009 microfarad, and we get 1.009 microfarads. This is 10.294 microfarads, and we get 10.96. Here's 112.2 microfarads, and we get 111.3. Here's 944.5 microfarads, and we get 989 millifarads, which is equivalent to 989 microfarads. All the capacitance readings met the specifications as stated in the manual. The lower nanofarad ranges had the least accurate specification of the group, and the highest range that we used had the least accurate specifications in the group. But as many times happens, the meter reads much better than the accuracy specifications in the manual. But again, this is only a sample of one. Comparing the resistance and capacitance accuracy for these 5 meters, the Uni-T seems to have the best accuracy specifications for the ohms range, and it sort of ties for the worst specifications in capacitance range. Now we can test some diodes. Here's the red LED with its forward voltage. Here's the yellow LED with its forward voltage. Here's the green LED with its forward voltage. Here's the Schottky diode with its forward voltage. Here's the small signal diode with its forward voltage. Here's the rectifier diode with its forward voltage. It's time for continuity check. Use our probe masters. Turn on the meter. We're in continuity mode. I'll have to be quiet and listen, see what it sounds like, and if it latches. It definitely latches. Let's try how fast it'll go. Well, it's not as fast as some of the meters, but it's fast enough for me. All right, logging. You can do logging with this 2 ways. You can use this cable, which is included, that is an optical interface to USB, and you can download the Windows software from Uni-T and hook this up to your Windows-based computer. I used Windows 11 ARM version running under Parallels on my Mac Studio, and it worked fine. The other option is you can buy for $29.99 a Bluetooth adapter that plugs in to the back, has a little battery in it, and with this you can go to your Android or iOS apps that Uni-T has and you can download. I was able to get the iOS ones working, but the Android one requires a GPS. And I don't know why it requires a GPS, but my tablet doesn't have a GPS on it, so it won't run. It keeps saying, I need permission to the GPS to search for your Bluetooth device. And I may figure out what that problem is someday, but right now I didn't worry about it since it works fine on the iOS devices. So I'm sure it's just my tablets at this problem. It also does graphing. Let's look at the pros and cons of this meter. Well, the good parts of this meter. It's third-party safety tested by ETL for the US and Canada. It has a 3.5-inch color LCD screen that looks pretty good. All but 2 of the readings met accuracy specifications as stated in the manual. You can store and graph readings on the local screen. It has an included USB interface cable with free software you can download. It has a reasonably priced Bluetooth option available, again with free software you can download. The not so good parts of this meter. The 490 volt reading missed the accuracy specifications by 155.4 millivolts. The 1 milliamp AC 100 hertz square wave reading missed the accuracy specifications by 38 microamps. Again, these 2 problems are probably just my unit, and again, it's only a sample of 1. And you can't use the meter while recharging the battery. A rechargeable battery, so you don't have to change the batteries. But if you do want to change the fuses, and I admit I blew the fuse on this once, and I don't know how I did it. I'm thinking that I blew the fuse with the charger because it uses the lower current to actually charge this. And my first charger that I put could go up to like 1.5 amps. And I think it must have definitely blew it, because this is like a 500 milliamp fuse. And so I had to take it, I had to open it up. And you don't have to take it apart. There's 3 screws here you leave alone because they hold the thing together. All you have to do is loosen this screw here, and then loosen these 2 screws here, and then take these little screws that are here out, and don't do what I did, which is drop them in, because if you drop them in the meter, you end up having to take the meter apart. And if you take the meter apart, you may not put it together right, and if you don't put it together exactly right, the logging stops working, because these little optical things get out of alignment. So when you put this meter back together, if you ever do take it apart, you got to be really careful to get those in line, and make sure you get the battery connector back connected, which I made all those mistakes. But for changing the fuses, you don't have to take it apart. You just have to take this back cover off, and it shows you the rechargeable battery, and it shows you the 2 fuses. And I have pictures of that. You'll see that. All right. So my conclusion. I like this meter. It did have a strange odor for the first 6 months I had it, and I believe that was from manufacturing, but I decided one day to leave it out of its case for a couple of days, and it seemed to make that strange odor go away. It was really a weird chemical smell, but now it's gone. That's really the only thing I didn't like about this meter. The other thing that took a while to get used to is charging it. You really have to consider how you're using it and when you want to charge it, because when you're charging it, you can't use the meter for anything else. So you got to let it sit there and charge. But I do like this meter. And between this and my other graphing meter, which is the Fluke 289, I'm going to keep this meter and I'm going to sell the Fluke. So I can see this screen better, which, again, for me, it's a specific problem. For most people, they probably could see their screen fine. This has a color screen. The graphics are faster in the graph mode. So I'm keeping this. And, $400 is a pretty hefty price to pay, but this has the graphing function if you need it. I wish that it could stay on and useful while it's charging, because it can only record as long as its battery lasts. So, I hope this helps. And this is Tom, N8FDY, saying 73, and take it easy.